Hello, thank you for sharing your time with us and thank you for joining us for the Open Policy Agent Deep Dive session. My name is Ash Narkar. I am a software engineer at Styra and I'm one of the maintainers of the Open Policy Agent. We also have with us Tim Hinrichs. He's the co-founder and CTO at Styra and he's also a co-creator of OPA. In today's talk, we will discuss OPA. We will talk about an API authorization use case in detail, talk about the new and the upcoming features being added to OPA, and get updates from sub-projects. So let's get started. Last year, we added the OPA Integration Index, which showcases all the open source projects OPA is integrated with. The purpose of this page is to make it easy to find a specific integration with OPA or to browse OPA integrations within a specific category like service mesh. The OPA Integration Index pulls information about an integration, its blogs, tutorials, videos, code in this one single place, which provides a good resource for integration authors to model their OPA integrations. A really good way to contribute to OPA is to write an integration with a different project and then have it showcased on the OPA website. So we hope to see more OPA integrations from y'all in the future. If we look at the cloud-native landscape, it's constantly evolving. You have new projects being added every day, new databases, new service meshes, and so on. So now if you're designing a system consisting of databases, API gateways, service meshes, you're likely going to deal with a lot of projects, some of which are shown on this slide, and your system is going to comprise of a lot of moving parts. So if we focus on security, specifically authorization for such a diverse system, you can imagine a scenario where each of these projects are written in a different programming language and each have their own way of controlling access, which may be tightly coupled to the underlying system. And so you end up having no visibility into the security posture of your overall system. Even from a point of view of flexibility, if tomorrow you wanted to change, say, the service mesh provider, you would have to spend time and effort in rewriting those same policies to conform to your new platform. And you might say, we'll just write up policies in docs and in wikis and we'll enforce them that way, until you realize you have tens, hundreds, or even thousands of microservices and that wiki approach is no longer sustainable. So what we need is a unified way to enforce policies across diverse systems in a highly performant manner. And this was one of the motivations behind creating the Open Policy Agent. The goal is to unify policy enforcement across the stack. So, what is OPA? OPA is an open source general purpose policy engine. When you use OPA, you decouple the policy decision making from the policy enforcement, so your services can now offload policy decisions to OPA by executing a query. So let's understand this using this figure. Imagine if you had a service, and it can be any service at all. It can be a Kubernetes API server, it can be your own custom service, an API gateway, Envoy, any service at all. Whenever your service gets a request, it's going to ask OPA for a policy decision by executing a query. OPA is going to evaluate that query based on the policy and data it has access to and send a decision back to your service where it gets enforced. So you can see that we have decoupled the decision making from the policy enforcement. The policy query itself can be any JSON value. So if you're doing Kubernetes admission control, the policy query could be like a pod manifest. Or if you're doing API authorization, the pod query could be the request method, the path, and so on. Since OPA is not tied to any particular data format, we say it's a general purpose policy engine. So what this means is that as long as you give some structured data to OPA, it's going to give you a decision back. And you write policies which make sense for that data, of course. Even the policy decision itself can be any JSON value, and then it's up to your service to interpret that decision and finally enforce it. So let's look at some of OPA's features. At the core of OPA is a high-level declarative language called as Rego. And with Rego, you can write policy decisions which are more than allow, deny, true, false, yes, no. So you can write policy decisions which are sets, which are objects. Basically, again, any JSON value or any composite value can be a decision. You can deploy OPA as a sidecar, a host-level daemon, or you can embed it as a library as well. All the policies and all the data OPA needs for evaluation are stored in memory. So you can think of OPA as a host-level cache for your policy decisions. OPA does not have any decision time dependencies, so it doesn't have to talk to an external service for making a policy decision. However, you can extend OPA to do that, but it's optional. OPA does provide some management APIs that allow you to pull policy and data from a remote service, upload status information to a remote service, and also upload decision logs to a remote service. Along with the core policy engine, OPA also provides a rich set of tooling that allows you to profile your policies, unit test your policies. There are also integrations with VS Code, with Vim, and so on. We also have the Rego playground which you can use to experiment with your Rego policies and also share them. So these were some of OPA's features: a high-level declarative language, multiple deployment models, management APIs for control and visibility, and a rich tooling set. So now let's look at the API authorization use case in a bit detail. So like I've said before, OPA is a general purpose policy engine. You can use it with all of these different projects without having to write a single line of code. You can integrate OPA with each of these projects. But for this talk, we will focus on the API authorization use case. So microservices improve the productivity of individual development teams by breaking down applications into smaller standalone parts. And hence many organizations today adopt microservice-oriented architectures. However, microservices do not solve age-old distributed system problems like authentication, service discovery, or authorization. In fact, these problems are more acute due to the heterogeneous and the ephemeral nature of microservice environments. Imagine you have tens, hundreds, or thousands of microservices, and each microservice needs to decide whether every one of its thousands of API calls per second is authorized or not. That's a pretty huge problem to solve. In fact, Netflix, who's one of the leaders in microservices, publicly talks about how important fine-grained authorization is and how strict the performance and the availability demands are at scale. So again, what we need is a unified way of understanding and controlling the authorization policies enforced by these diverse systems. And by now, I hope the solution, you may have guessed it, is OPA. So as mentioned before, OPA has multiple deployment models, and today we are going to focus on integrating OPA with your service mesh or network proxy so that you can enforce policies without having to change your services at all. So let's look at an example using Envoy. Envoy, if you may not know, is a layer 7 proxy and communication bus designed for large modern service-oriented architectures. So if you're deploying your application, say on top of Kubernetes, inside your pod, you have your application container as well as an Envoy sidecar as well. So the way this typically works is that when your service gets a request, it's going to be handled by Envoy, which then sends it to your application container, gets a response back, and sends that back to the end user. You can now inject OPA in this flow using Envoy's external authorization filter, which calls out to an external authorization service to check if an incoming request is allowed or not. In this case, the external authorization service is going to be OPA, and Envoy is going to provide it the entire request context so OPA can make an informed decision about the fate of the incoming request. OPA evaluates that query, sends a decision back, and if OPA denies the request, Envoy sends a 403 back to the client. If OPA allows the request, like before, Envoy sends it to the application container, gets a response back, and sends that response back to the end user. So you can see here again that we have decoupled the policy decision making, which is handled by OPA, and the policy enforcement, which is handled by Envoy. So in this way, you can integrate OPA and Envoy, and you can enforce custom ingress policies, egress policies, service-to-service policies in a highly performant manner. Now I'm going to hand it over to Tim to talk about the new and the upcoming features being added to OPA.
Okay, thank you, Ash. That was great. So now we're going to turn and look at new and future features. So the first new feature that we have available here is an update to WebAssembly. So remember that WebAssembly is this compilation approach that OPA supports that will take OPA policies and compile them down into WebAssembly instructions. So WebAssembly is just a binary instruction format for a virtual machine. And so one of the benefits here is that you can take policies now, compile them down into WebAssembly, and then evaluate those policies in any programming language that has a WebAssembly runtime available. So that's pretty powerful because it reduces some overhead from just communicating with OPA when it's running as a sidecar. But it also makes it possible to run these policies in environments that, for example, don't allow you to run sidecars. So we've had pretty good support for WebAssembly. We can compile the entire language down into the binary instructions for WebAssembly. But what we haven't had support for entirely is the built-in functions that OPA provides. So this update really supports those categories of built-ins described there. So arithmetic, sets, arrays, some type checking built-ins, and most of the string manipulation operations as well. So that's new, and that support will continue to grow. The other thing that's a bit new is that the OPA build command has been updated. And so now when you're running the OPA build command to construct these WASM bundles, the format has changed a little bit. And there were actually a couple of OPA build updates that I'll get to in a little bit. The next new update here is really a new tool, so a benchmarking tool. So this has sort of been inspired by Go's benchmarking tool suite. The idea being that, let's suppose that you have one of these high frequency or high performance use cases. And so what you really need is some good visibility into how long it takes to evaluate the queries you've written. And so that's what the OPA benchmarking tool is doing. In contrast, the OPA profiler does give you similar kinds of output, but what it really does is it tells you where in the code, where in your policies there are hotspots. So which parts of the code take the longest. But what OPA profiling doesn't really do a good job of is giving you absolute numbers around how long it takes to do evaluation. And so if you're using OPA Bench, you can see some of the output shown over there on the right-hand side. So the idea is OPA Bench will run that same query that you give it many times in order to give you statistically significant results. And so that's what you see under here in these histogram results. And then this nanoseconds per op is probably the one number, if I had to pick one, that you'd care about there. In order to use the OPA benchmark command, you can use just OPA bench. So bench is a new subcommand within OPA. And then you give it some data to load, so the policy that you want to load, as well as the query that you want to evaluate. So that's that data.rbach.allow. And so it'll just go ahead and run that query many times and then give you those results that you see on the right-hand side. The other way that you can use the benchmarking tool is through OPA test. So you can go ahead and run OPA test the way you normally would. And then if you give it the -- bench flag, it'll go ahead and give you benchmarking results as well. So that's exciting. If you're looking for high performance queries, I'd definitely check it out. The next one on the list is decision log mutation. So this is another new feature. Remember that OPA has the ability to create and record all the decisions that it's making in what I like to call a high fidelity JSON log. So every time OPA makes a decision, it will record the input that it was provided as well as the decision that it made, and then it can sort of send these in batches off to some external service. So we've had for a while the ability to, within OPA, write policies that dictate which pieces of a decision log entry should be removed or deleted from that entry. Why? Because maybe that particular piece of data contains sensitive information. Maybe you've passed in a jot, and you want to make sure that nobody can use that JOT before it expires. So what's new, in fact, is that now OPA supports the ability to not only delete, but to update and add information to those decision logs. And so that's kind of what you see here. This is sort of similar in spirit to the Kubernetes mutation policies, where what you're doing here is writing a policy that describes basically a JSON patch. In this case, it's saying, here's a path, and I want to set the value of that path to this variable X. Now, one thing to keep in mind is that when OPA makes these changes to a decision log entry, it does actually record what it made changes to. And so, therefore, there's no way to change the log without someone being aware that it was changed. Thanks to Domingo Kaiser at Front Door for contributing this feature. There are a few additional features that I'll mention here. So one of which is some enhancements to partial evaluation. So remember that partial evaluation is a compilation technique. The idea is that you want to evaluate as much of a policy as you can at the time you build the bundle or at the time you compile that policy as possible. And in so doing, the hope is that you've got less work to do at evaluation time, therefore yielding faster evaluation results. So in the past, there have been some restrictions on what portions of the policy get evaluated. Here in the upper left-hand corner, what you see is the purple here is indicating a portion of the policy that is known. So that portion of the policy has no dependencies on the input. And so with these new enhancements, OPA can go ahead and evaluate that entire section of the policy. And obviously, what it can't evaluate at the time it's compiled is anything that depends on input. And so that's that sort of lighter circle there. That's pretty exciting. One of the byproducts of that is also an updated OPA build command. So the idea behind OPA build up to this point has been that you can use OPA build to generate WASM binaries, but we realized that the OPA build command can also be used now for creating just regular Rego bundles. So if you've got a directory of Rego files and you want to build a bundle so that bundle could be distributed to OPAs in real life, then you can go ahead and use OPA build, and then you just give it the Rego files that you want to include in that bundle. That second command there allows you to not only build an OPA bundle, but also utilize that partial evaluation compilation technique. And effectively optimize the bundle for evaluating the query that you've given it there. So in this example/allow is the path to the policy that you actually want to optimize for. And then the -01 is telling OPA build to go ahead and optimize it at level 1. So what we're trying to do here is enhance the usability of compilation features like partial evaluation so that you can just choose an optimization level and in so doing tell OPA how aggressive to be when it comes to building that bundle. And then, like we said a slide or two ago, you can still use OPA build to go ahead and target and build out WASM bundles. Here, though, all you need to do is add the -t flag for target and tell the OPA build command to target WASM. If you don't provide a -t by default, it's going to just target Rego. The third new feature that I'll mention here is that there's now a new parser for Rego. So this has been pretty nice. In terms of performance, it's roughly 100% faster, so almost 2x faster on nearly all the benchmarks. And then there's some cases that it's much faster. So this is one of those examples where you just download a new version of OPA and suddenly it starts running a bit faster. And that's the same kind of thing that we see in this lower right-hand corner, this optimization for group by idioms. So it turns out that there are some common and somewhat expensive patterns that we've seen people using when they're writing Rego. So this particular kind of pattern is basically taking, in this example, imagine you had a list of network interfaces and for each network interface, what port it's been opened on. And so let's suppose that you want to turn that sort of flat collection of data into really a dictionary or a map from the interface to the array of ports that are open on that interface. Well, that's a kind of a group by idiom. And so anyway, in the back end, what we've done is we've identified, there's an optimization that now looks for that kind of pattern and goes ahead and implements it more effectively. So instead of it being an n squared operation, now effectively it becomes a linear time operation. Again, another great example where you just upgrade OPA and your policy starts to run faster. That's it for features that are already in the latest release of OPA. So now let's turn to some upcoming features, some work that is coming in that you may want to know about. So the first one is that bundles. So remember bundles, as I just explained, but remember OPA uses bundles to sort of download policy from an external service. One of the new features here is that those bundles can now be signed, and so the idea being that OPA, when it receives a bundle, when you configure OPA, you can tell it, well, only activate bundles that have been properly signed, and you can give it all the keys that you need to. And so if OPA downloads a bundle and that bundle has not been properly signed, it will simply refuse to activate it and refuse to use it to do enforcement. So that's pretty powerful when it comes to ensuring the integrity of the bundles and the policies that OPA is enforcing. Thanks to Ash and Ashish for working on that. The next new feature that's coming is always-on tracing. So one of the things that sometimes people ask for is, well, okay, my service has asked for a decision from OPA. OPA gave an answer. Maybe it was an allow-deny decision, and so the response was simply true-false. But that service maybe now needs to know a little bit more about why that decision was made. And so one of the things we're working on is ensuring that each time OPA makes a decision, that it can provide a little bit more information back to the service if requested that explains why that decision was made. So in this example, what we might do is just say for each of the virtual documents, for each of the variables that are used in the policy, which ones were actually successful and which ones were not. And so if you structure your policies correctly, that's a good way of getting a basic explanation out. Thanks to Patrick for working on that. The third upcoming feature is IntelliJ. So OPA does have a plugin for VS Code that does things like syntax highlighting, evaluating policy right there in the editor, doing testing, doing building, that kind of thing. And so we've got some folks working on doing the same thing for IntelliJ. So thanks to Frankie Assad, Vincent, and Anders for working on that. That together so that would give you both IntelliJ, VS Code, and then in addition, don't forget about the OPA Playground when you're looking for environments for developing policy. The last one on this slide is a new integration with MongoDB. So the idea here is that there are a number of databases where, SQL databases as well as Elasticsearch, where there's been some early work on taking OPA policies and compiling them or translating them down into the native query language for the database, compiling them down into SQL or Elastic's query language, so that you can write policies, authorization policies about, for example, which fields within a database a user is allowed to see, and then compile them down and infuse them, sort of splice them into a query that's being sent to that database, so that it's the database itself, the database query engine itself, that is enforcing the authorization policy. And so this work with Mongo is looking at the same kind of thing. Thanks to Vineeth and Ash for working on that. Okay, so that about does it for the new and upcoming features. So now let's turn and do a few updates on sub-projects within OPA. So Gatekeeper, I'd expect most folks to have a sense as to what Gatekeeper is. So very quickly, Gatekeeper takes OPA and runs it and enforces OPA policies as a Kubernetes admission controller. The idea being here that each and every time some end user goes ahead and tries to create a new pod or an ingress, they go ahead and send that request to the Kube API server. The API server sends that request through authentication, authorization, and finally admission control. And it's there at admission control that Gatekeeper hooks OPA in order to make decisions as to, is this pod or ingress configured correctly and safely for it to be deployed onto the Kube cluster. In terms of new features, there's a good list there. I won't go through all of them. I will mention Gatekeeper did go through a CNCF security review successfully, so that was great. And then in addition, there's been the addition of pod security policies added to the Gatekeeper policy library. So those same pod security policies that are available in upstream Kubernetes. There are now analogous policies that are available in Gatekeeper. And that brings up the point that Gatekeeper also, remember, has a number of pre-built policies. I think the list on the right there is pretty well up to date. The biggest new one is obviously the pod security policies that I mentioned. So if you're interested in using OPA for admission control in Kubernetes, I definitely suggest you check out Gatekeeper. There is now a second sub-project within OPA called ConfTest. This has been announced publicly, but this is the first KubeCon where we've gotten a chance to talk about it. So ConfTest is an application of OPA where it is designed to help developers run policies over configuration files. So those configuration files might be YAML files for Kubernetes or INI files, XML, Docker. You see some of the examples there. The idea being that you can write OPA policies over really any structured data that, at least from OPA's point of view, looks like JSON. And so ConfTest really makes it easy to run OPA policies over configuration files, whether those configuration files are on your developer laptop or, in a CI/CD pipeline or really anywhere. So there are a couple of cool things about ConfTest to mention, one of which is that list of input formats that the ConfTest supports. So remember, OPA today, raw OPA, supports mainly JSON and YAML, but ConfTest brings in a bunch of other input formats and turns them into effectively a format JSON that OPA can handle. And so that's quite powerful. It also has a number of output formats. So there's a user-friendly output format that just prints out the results of those policies. Here at the top, you can see an example of that. You simply run ConfTest and say test this deployment.yaml file, and then it'll print out nicely exactly what the failures were. So that's a nice thing from a usability point of view. And then it also has a number of additional output formats that are supported to help with scripting and using this in an automated process. Finally, it's got a number of integrations for CI/CD pipeline and CI/CD tooling that you see there, Circle CI, Tecton, and GitHub Actions. That's really powerful because a lot of people do like using ConfTest in CI/CD pipelines to make sure that structured configuration files will pass the organization's policies before they're actually merged into that Git repo. Welcome to ConfTest as a new OPA project. I certainly recommend you check it out if you're looking at writing OPA policies over configuration files. Okay, so that does it for us for now. Thanks so much for giving us your time. Definitely check us out online. Remember, we're at OPA's at openpolicyagent.org. And then there's an active Slack channel, so definitely hop on there and ask questions. There's a community there that would would love to help you out. So that's it for now. We'll open it up for Q&A.